Hey, this is Mr. James, and in this video we're going to be talking about the distance formula. Oftentimes we need to find the distance between 2 points on a coordinate grid, such as perhaps this point right here and this point right here. It would be very easy to find the distance between those 2 points if perhaps they were directly across from each other horizontally, like these 2 points in green. We could just count the distance between them using the grid marks. 1, 2, 3, 4. Those are 4 apart. Or perhaps if they were just vertical, like this point and this point. Those are 1, 2, 3, also 4 units apart. But it's a little more difficult with these two that are kind of diagonal from each other. So to solve that problem, we're going to use the Pythagorean Theorem. What we're going to do is draw in the 2 legs of the Pythagorean Theorem. This is a right angle here because it's on a grid. And we're going to count how long the 2 legs are. 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5. That's also 5. And then, using the Pythagorean Theorem, a squared plus b squared equals c squared, we can solve for the missing side of this right triangle. So here's a, here's b, and of course the hypotenuse, the longest side, is going to be c. And so we have 5 squared plus 5 squared equals, I guess we'll leave this as c. That's the distance we're looking for. 5 squared is 25. Add them together, you've got 50. And then remember to undo or cancel out that square, we're going to take the square root. They're inverse operations. And so the square root of 50, well, you could pop that in your calculator and get a decimal, but we're going to tend to simplify our radicals here. So the square root of 50 simplified, well, let's see, I can take out a 25, and the square root of 2 is left, and so that'll be 5 square root 2. Of course, if you're asked to use your calculator and get a decimal, you could also do that. So here's the square root of 50. Okay, 7.07. And just to make sure I did my math right, let's check the 5 square root 2. Okay, right here. 7.07, perfect. So that means that the distance is either 5 square root 2 in exact radical form, or 7.07 in rounded decimal form. Now, counting the grid marks like we just did before is pretty easy if you've got a graph in front of you. But what if we've got problems like this, like 15, where they just give us 2 points and there's no graph? Well, we can solve that by using something called the distance formula. Here's how the distance formula works. I'm going to do the calculations I did exactly before, but instead of using 5 and 5, I'm going to use the letters A and B. And I'm going to rearrange them into what we call the distance formula. So remember, this all starts with the Pythagorean Theorem. A squared plus b squared equals c squared. But instead of a and b, think about this. What's another way you could find the distance between these 2 points without actually counting? Well, if you think to the slope formula, we do that already. y2 minus y1 over x2 minus x1. This y2 minus y1 is actually this distance right here. So I could call this y2 minus y1. And this x2 minus x1 is actually this distance right here. So this b I could call x2 minus x1. That's exactly what we're going to do. We're going to come back to the Pythagorean Theorem and write in, instead of a, we'll write y2 minus y1 squared. And for b, we'll write in x2 minus x1 squared equals c squared. Now there's one last step here to make the distance formula. When we're solving for distance, c right here, we need to make sure we have c on the other side of the equation, and we don't, we have c squared. And so to undo that squared, we will take the square root of both sides, like this. And so the distance formula, which I'll write down here, is actually the square root of y2 minus y1 squared plus x2 minus x1 squared. Now what you're going to notice is it might actually just be easier to use the Pythagorean Theorem like I did here most of the time, but I'll also show you how to use the distance formula. Let's try the 4 examples below. Alright, let's take a look and find the distance between these 2 points. Since I have a grid, I might as well use Pythagorean Theorem. Alright, there's my right triangle. It looks like it is 1, 2, 3, 4, 5, 6, 7 by 1, 2. Okay, and this is my C, here's my A, here's my B. All right, so that means that to solve for C, the distance, I would do 2 squared plus 7 squared to get the distance squared. 2 squared is 4, 7 squared is 49. Add them together, you get 53. And to get the distance, you have to do the square root of 53. Now it just so happens that the square root of 53 is a prime number. 53 is a prime number. So there's actually no perfect squares that go into 53. So we would leave it like this. Or you could get a decimal approximation, and the square root of, the square root of 53 is 7.28. So 7.28. And depending on what's asking for, whether it's wants an exact form or decimal form, either of these could be your answer. Pause the video here and try and do 14. Pause the video now. Alright, hopefully you've tried it out. Again, we can use Pythagorean Theorem here to find the distance. Just make that right triangle, just like we would for slope, kind of rise over run. In fact, this has a lot to do with slope. And then count this side, which is 1, kind of our run. Our rise, 1, 2, 3, 4, 5, 6. 6, so then here's C, here's A, here's B. So this is going to be 6 squared plus 1 squared equals C squared. 6 squared is 36. 1 squared is 1. Gotta take that square root of both sides. Oh, sorry, I haven't added them together. 37 equals C squared. And we take the square root of both sides. And the square root of 37, well, 37 is also prime. There are no perfect squares that factor into it. 4, 9, 16, nothing. So either your answer will be the square root of 37, or you could put it in a calculator. And the square root of 37 is 6.08. 6.08. So depending on the context, either of these could be your answer. Let's try doing 15 now. And I'm going to first use the distance formula and then show you how you could do it without using the distance formula. Since there's no coordinate grid like we saw in the last problem, I'm going to go back up and use this formula right here. If it helps you to label the points, you can do that. x1, y1, x2, y2. And then remember the formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. And all we've got to do is plug our numbers and simplify. So y2 is negative 5, y1 is negative 4 squared, plus x2 is 4, x1 is 8 squared. Don't forget the square root over the whole thing. And now we can simplify the first. Remember, minus negative will be a positive, so negative 5 plus 4 is negative 1 squared. 4 minus 8 will leave us with negative 4 squared. There's a square root over the entire thing. Negative 1 squared, negative 1 times negative 1. Remember, negative times negative is a positive, so negative 1 squared is 1. Negative 4 squared, negative 4 times negative 4 is 16. Don't forget the square root of the whole thing. And then 1 plus 16 is 17, and so the answer is the square root of 17. And you can leave it like that because we can't factor that. Or you could put it as a decimal and get square root of 17, the square root of 17 is 4.123. So I'll leave it at 4.12 right here. So either of these right here would be your answer, the distance between the 2 points. However, I like to do this a little bit of a faster way. So instead of doing this whole formula out, here's what I like to do. I will still like to use the Pythagorean Theorem. Okay? And for A and B, I'll just figure out the differences between the y's and the differences between the x's, just like I would for slope. So you could also do it this way. How far is it from negative 4 to negative 5? Well, you're going down by 1. How far is it from 8 to 4? Well, it looks like you're going down by 4. And now I'll just use that as my A and my B in the Pythagorean Theorem. So then I just have negative 1 squared plus negative 4 squared equals c squared. And then just work the Pythagorean Theorem. This is 1. That will be 16. Add them together, you get 17. Then take a square root, and you get the square root of 17. just like we did over here. So whether you prefer to use the distance formula like I did over here and do more steps, or use the Pythagorean theorem and find the differences just like we did for slope and do less steps, either one is up to you. Pause the video here and try and do 16, either using the distance formula or Pythagorean theorem. Pause the video now. Alright, so I'll show you how to do it now, first by using the distance formula, and second by using the straight Pythagorean theorem. So, for the distance formula, let me write it out one more time. The square root of y2 minus y1 squared plus x2 minus x1 squared, square root over the whole thing, versus the Pythagorean theorem, which is a squared plus b squared equals c squared. Both will get you the answer, and they're both actually really the same thing. This one just has a little more training wheels on it. So, let's see. For this one, this is x1, y1, x2, y2. So, okay, let's see. Y2 is negative 4. Y1 is 1 squared plus x2 is 7. X1 is 5 squared. And remember, don't forget the square root of the whole thing. And then negative 4 minus 1 will get me negative 5 squared. 7 minus 5 will give me 2 squared. Don't forget the square root of the entire thing. Negative 5 squared, negative 5 times negative 5 is 25, plus 2 squared is 4, and again the square root of the whole thing. 25 plus 4 is 29, and there's a square root, and 29 is a prime number, so we cannot factor that. 4 won't divide it, 9 won't divide it, that's the end of the road, unless we were to write it as a decimal. And the square root of 29 is 5.385, so let's call it 5.39. 5.39, and that's using the distance formula. The distance formula is nice because it tells you exactly where to put all the numbers, where to put the x1, where to put the y1. However, it's definitely a lot more work. Easier, but more work. Let's try the Pythagorean theorem way. Alright, what's the difference in the y's? Well, from 1 to negative 4, I'm going down by 5. What's the difference in the x's? Well, from 5 to 7, I seem to be going up by 2. Drop in the Pythagorean theorem. Here we go. So that means we'll have negative 5 squared plus 2 squared equals c squared. This is 25. 2 squared is 4. Add them together, you get 29. And take a square root. And the square root of 29 is where we have to leave it. Or, I guess you could, again, put it in the calculator and get 5.39 just like before. So I prefer to use the Pythagorean theorem whenever I do these problems, just like I did up here. However, if you want to, you may always use the distance formula to help you out. It's one more thing to memorize, but it does tell you where to put all of those points exactly. I hope this has helped you be able to find the distance between 2 points on a coordinate grid. Be sure to go back and rewind if you need to watch anything or record any information, and be ready for a video check at the start of next class. Have a great night.